And the next question is here, how would you name the following compounds? Some carbon compounds are given there and we have to find out name of that carbon compound. And there are three in number. So we will start with the first one. The first one, carbon compound is given there whose structure is only given. So we have to name that structure. So to find out the name of that structure of carbon compound, we have to first of all look at the two things. We have to calculate the number of carbon atom in that particular structure, and after that we have to find out what type of functional group is there in that particular structure. So if we look at it, we find out that the functional group which is attached to that carbon compound is bromine. So bromine is there, and according to the standard, the bromine always comes in the prefix side of the name of carbon compound. So that's why the bromo is come first in the name of that carbon compound. After that, we have to calculate the number of carbon atom in that particular structure. So there are two carbon atoms. So according to two, it is named for ethane because there are two carbon atom in the ethane. So that's why the ethane will become after the bromo. So the name of that carbon compound is bromoethane, whose structure is given in the first. After that, in the second, we have to use the same procedure to find out the name of that particular carbon compound. In that, the number of carbon atoms are 1 and the functional group is CHO. The CHO is aldehyde group and it is named as Al. So accordingly, Al always come on the fixed side of the carbon compound name. So that's why Al will become at the last, and according to the number of carbon atom present in that structure, it will be named as methane because in the methane the number of carbon atoms are 1. So it is a structure diagram for methanol. After that, in the third one, the functional group which is present there, there is no functional group in the third one. There is only one unsaturated bond there between the carbon-carbon atom. That means to say it is suggesting for YNE. YNE, because when there is a single bond between the carbon-carbon atom in the whole structure, it is named as ane. If there is a two bond in any of carbon atom in the long chain carbon atoms, it will be named as ene. And if there is a triple bond in between the carbon atom in any of the carbon atom in the long chain, it is named as ene. YNE. So after that, we have to calculate the number of carbon atom present actually in that structure. So there is a 1, 2, 3, 4, 5, 6. So 6 carbon atom is there. So that's why it is named as hexane, because in hexane there is a 6 number of carbon atom. So it is a name for hexane. So it's a structure diagram for hexane. So according to that, we can find out the name of any carbon compound whose structure diagram is given to us. So there is a two-step to do that. First one is we have to find out what functional group is there in that particular carbon compound whose structure diagram is given to us. The second thing is we have to find out the number of carbon atom in them. And third thing is also there. If in some cases, like in the third thing is that we have to find out what type of covalent bonding is there in the carbon compound whose structure diagram is given to us. If the carbon-carbon bonding is single covalent bond, then it is a ane. If there is a double covalent bond in between the carbon atoms, it is ene. If there is a triple bond in between the carbon atom, it is the structure diagram for ene. YNE. So the next question is, why is the conversion of ethanol to ethanoic acid an oxidation reaction? We know the chemical formula for ethanol first of all. That is CH3CH2OH. Ethane stands for 2 carbon atoms. Accordingly, it has 2 carbon atoms, C1 and C2, and the number of hydrogen atom in ethane is 5 because the one functional group is also there. So the functional group which is present in the ethanol, it replaces one of hydrogen atom. So that's why the ethanol having the 5 hydrogen atom, 2 carbon atom and 1 OH group. So this is a formula for ethanol. And we have to oxidize it. That is only possible in presence of in presence of some oxidation agents. So that oxygen agent reduce the ethanol, or you can say add the oxygen in the ethanol, and the ethanol become ethanoic acid. So that's why we need the oxidation agent for converting the ethanol to ethanoic acid, and that oxidation agents are potassium permanganate and potassium dicarbonate, that is K2MnO4. That is a potassium permanganate. This is a one kind of the oxidation agent which add oxygen in the ethanol to become a ethanoic acid or acetic acid. The next is a mixture of oxygen and ethene is burnt for welding. Can you tell why the mixture of ethene and air is not used? So the chemical reaction is given there. In that chemical reaction, this is particularly representing the ethene, ETHYNE, ethene. This is a formula for ethene or the structure for ethene also. When it will be burned in presence of oxygen, it gives us any carbon compound which is burned in presence of oxygen, it gives us carbon dioxide, water and heat. That is given there in case of ethene and air consumption also. So when ethene burn in the presence of air, it gives us carbon dioxide, hydrogen and water, and the same chemical reaction is given there. That equation is written based on the carbon-carbon structure present in the ethene. The formula for ethene is C2H2. Because the carbon-carbon atom is containing the triple bond in between them, so that's why it is written as like that. If we calculate, the number of hydrogen atom and carbon atom will be same in that also and in that also. But the 2 molecules of ethene are taken there in that particular chemical reaction, and 5 molecules of oxygen are taken here in that particular chemical reaction, because to balance the chemical equation. Because now the question is why we don't take the mixture of the both ethene and air. Because ethene burnt in the presence of a large air. If there is no that amount of air present in the burning of ethene, then it will be give us a salty flame. That is an incomplete consumption of that ethene. So that's why we need a large amount or big amount of air for burning of the ethene, and it is give us temperature around 300 degrees Celsius for complete combustion. So that particular temperature is not easy to maintain. So that's why we don't take the combination or the mixture of ethene and air particularly. Next question is, how would you distinguish experimentally between an alcohol and carboxylic acid? The alcohol and carboxylic acid is basically distinguished by their reaction with carbon and hydrocarbons. Basically, alcohol do not react with any hydrocarbon or carbon, right? But carboxylic acid, when react with the carbonate or hydrocarbonate, it always gives us salt, water and carbon dioxide. So this is the difference between the alcohol and carboxylic acid, and we can distinguish the both through this experiment. What are oxidation agents? Oxidation agents are those agents which is mostly used in the process of adding the oxygen in particular reactant to give a product that is oxidized product. So the example that we have in that chapter is of converting the ethanol to ethanoic acid. In converting the ethanol to ethanoic acid, we need an oxidation process, and in that particular oxidation process, we need some oxidation agent that are potassium permanganate and potassium dicarbonate. So these are the some oxidation agent which are used in the process of converting ethanol to ethanoic acid. That is a completely oxidation reaction. Would you able to check if water is hard by using detergent? Yes, we can check it if water is hard or not. Detergent having the ammonium or sulfate salt of long chain carboxylic acid, that is COOH. That is having the long chain of carboxylic acid, salts, aluminium and sulfonate. Unlike soap, they do not react with the calcium and magnesium present in the hot water to form a scum. So that's why they give a good amount of lead in respect to the water is hard or soft. That means to say detergent can be used in both soft and hard water, but it can't be used to check is the water is hard or a soft. If we want to check that water, we need a soap instead of a detergent. People use a variety of methods to wash clothes. Usually after adding the soap, they beat the cloth on stone or beat it by a paddle, scrub with a brush, or the mixture is agitated in a washing machine. Why agitation necessary to get clean clothes? Because the agitation basically produce the micelles. The micelles, that is a combination of hydrophobic and hydrophilic, uh, and that hydrophilic and hydrophilic, that means to say the ion is only produced when there is some action happen on that. That's why we do scrubbing, we do beating the clothes and etc. The next question is from the exercise. Ethene with the molecular formula C2H6 has how many covalent bonds? We have to check it first. Ethane. We know that ethane having the formula C2H6. So accordingly, how many covalent bond is there? So there is a 2 carbon atom, CC, and the rest of the atoms are of hydrogen. So accordingly, we can calculate how many number of bonds are there by drawing its structure. So this particular line is defining the bond. So we have to calculate that number of lines to find out the number of covalent bond in that particular formula of ethane. So this is the first bond, this second bond, this is a third bond, this is a fourth bond, this is a fifth bond, this is a sixth bond, and this is a seventh bond. So there are the 7 covalent bonds in that particular carbon compound. So answer is B. Butane, that is butane plus cation, is a 4 carbon compound with a functional group of cation. Because ONE, 1 is stand for cation and it is having the structure like C double bond with O. While cooking, if the bottom of vessel is getting blackened on the outside, it means that the food is not cooked completely, the fuel is not burning completely, the fuel is wet and fuel is burning completely. The answer is B. The fuel is not burning completely, so that's why the blackened is there in the washer. While cooking, if the bottom of vessel is getting blackened on outside, that means the fuel is not burning completely. Explain the nature of covalent bond using the bond formation in CH3Cl, that is chloromethane. So in CH3Cl, let's see the nature of covalent bond formed. Carbon can neither lose 4 electrons of its electron nor gain 4 electrons. So that's why it do the sharing. So because to lose and to gain, the large amount of energy is required to become unstable or to get the octet property. So that's why to complete this octet, it do sharing of the 4 electrons with other elements. So that is a covalent bond. And how that covalent bond is formed? It is there. Here you can see the carbon is sharing 4 of its electron with one electron of hydrogen atoms and 1 electron with the chlorine. So that's why it is chloromethane, because there one chlorine functional group is also attached with that particular methane carbon compound. Draw the electron draw structure for the same. So that we will cover in the next video.